Edexcel A-Level Maths, Pure Paper 2, October 2020, Question 7. Figure 1 shows a sketch of the curve C with equation y equals 4x squared plus x all over 2 root x minus 4 log natural x. For part A, we need to show that dy by dx equals 12x squared plus x minus 16 root x all over 4x root x. So for this, we're going to differentiate a fraction, which means we need to use the quotient rule. The quotient rule is if y equals u over v, where u and v are functions of x, then dy by dx equals v du dx minus u dv dx all over v squared. So letting u equal the top of our fraction, 4x squared plus x, differentiating this gives us du by dx equals 8x plus 1. And we're going to let v equal the denominator, 2 root x. Remember, root x is just x to the half, so differentiating this gives us x to the minus a half. Putting this into our formula for the quotient rule, we get that v, which is our 2 root x, times du by dx, which is 8x plus 1, minus the u dv dx, so 4x squared plus x times x to the minus a half, all over the square of the bottom, so 2 root x all squared. And we've got to remember to differentiate our 4 log natural x as well, so that's minus 4 over x. We now need to simplify this to get it into the form that's required. So expanding the tops, we get 16 times x to the 3 over 2 plus 2x to the half from the first part, and then minus 4x to the power of 3 over 2 minus x to the half. The bottom squares to make 4x, and we've still got that minus 4 over x on the end. On the top of our fractions, we've got some like terms to collect. So they come together to give 12x to the 3 over 2 plus x to the half all over 4x. And then the second fraction, I've just multiplied top and bottom by 4 to give it the same denominator. So that becomes 16 over 4x. Bringing our fractions together gives us 12x to the 3 over 2 plus x to the half minus 16 all over 4x. And then just looking at the form that we're aiming for, almost there. So if we just multiply top and bottom by root x, we get 12x squared plus x minus 16 root x all over 4x root x as required. The point P, shown in figure 1, is the minimum turning point on C. For part B, we need to show that the x-coordinate of P is a solution of x equals 4/3 minus root x over 12, all to the power of 2 over 3. So in part A, we worked out a formula for dy by dx. We know that point P is the minimum, so dy by dx must equal 0, hence we can set our answer to part A equal to 0. Multiplying by the bottom gives us that 12x squared plus x minus 16 root x equals 0. Now to turn this into a formula like the one we're looking at, we can see that in the formula x only appears in 2 places, which we've got it in 3 places. So if we divide by root x, we end up with an equation with x in only 2 places. So we end up with 12x to the 3 over 2 plus root x minus 16. Again, compare this to what we're aiming for. In the answer we're aiming for, 12 is on the bottom of a fraction. So let's divide everything through by 12 to give x to the 3 over 2 plus root x over 12 minus 4/3. This is looking a lot more like the answer now. So subtracting the root x over 12 and adding 4/3 to both sides gives us x to the power of 3 over 2 equals 4/3 minus root x over 12. Finally, doing both sides to the power of 2 over 3 will cancel out on the left, so we get x comes over to the right to give us 4/3 minus root x over 12 to the power of 2/3 as required. For part C, we need to use the iteration formula xn plus 1 equals 4/3 minus root xn over 12, all to the power of 2 over 3, where x1 is equal to 2, to find the value of x2 to 5 decimal places. So to find x2, we're just going to put our value of x1 into that iteration formula. So x2 is equal to 4/3 minus root 2 over 12, all to the power of 2 over 3. Putting that into the calculator gives us an answer of 1.13 894 to 5 decimal places. For part 2, we need to find the x-coordinate of p to 5 decimal places. So we're just going to keep using our iteration formula, putting each answer back in to get the next answer. So x3 is going to equal 4/3 minus the root of our previous answer over 12 and all to the power of 2 over 3. Note, however, although I've written the previous answer to 5 decimal places here, make sure you use the answer button on your calculator to put the entire answer in with all its decimal places, otherwise we're going to get rounding errors. Putting this into the calculator gives us 1.156928424. At this point, using the calculator, I typed in the formula. Instead of putting my latest value for x in, I use the answer button, which then allows me to just keep pressing equals and getting the answers one after the other. So putting our new answer in gives us an x4 of 1.156494678. I then get x5, and what we're looking for is to keep on doing this until our answers to 5 decimal places stay the same. So at the minute, they're still changing that little bit. These two have got different answers to 5 decimal places. But once we get to x7, we can see that to 5 decimal places, this is exactly the same as x6. So that must be our answer, rounded to 5 decimal places. We get 1.15650. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.